All right, the recorder is started. Give it another minute. Well, might as well get started now, because everything is recorded anyway. No need to wait for the rest of the class. So this is a document that I generated. Okay, so it is computer generated, but I think it is. It's not like I just gave it like one little prompt. This was the at the end of a really long conversation with your ChatGPT. So I asked ChatGPT to summarize, certain aspects of that conversation into a kind of more condensed version of the entire conversation. So I want to say that because it really shows that you cannot just say, "Oh, okay, I want something like this." It doesn't give you the result right away. You kind of need to guide it, have a conversation, double check its references, and so on. So I will show you what this has. Okay, so let me open the document, and this is the document. It's not formatted in a very mm, uh, you know glamorous fashion. Okay, it's all black and white, but that's the whole point. Okay, the whole point is, I want to just kind of bring up, the five quote unquote dimensions of cognitive growth in computer science. This is actually a title that the AI chose. It is actually correct. Um, so it introduces five key dimensions or five different, axes of thinking and problem solving that shape success in the computer science or computer information science field. Each dimension can be developed through education, practice, and reflection. In other words, you can do something. I can do something about it. Okay. And that's the most important part. It's not something that you're either born with or you don't have it. Okay. Because it's pointless to talk about those things, right? We talk about things that we can change. Understanding them can help you grow into a stronger and more adaptable professional. So, since you guys are in CISP 300, you're at the very beginning of this path. And I think understanding this at the very beginning of the path is much better than understanding this when you're like 10, 15 years into the career. And then you go like, I'm running up against the wall. What can I do? Because that's going to be a little bit more painful, by that time. So it starts with an explanation of the dimensions. One is analytical depth. It is about breaking down complex problems into smaller and manageable parts. In other words, you take a big chunk of thing, you identify the key pieces, you look at each key piece, and then you break it down into even smaller pieces, and so on. It is the job of a grinder. Okay, this is what a grinder or a food processor does. Okay, it just chop things until you cannot recognize what it was to begin with. The second one is called abstraction capacity. It is seeing a pattern instead of just the individual pieces. Okay, so in other words, when you're writing a program is an abstraction of how we do things. Okay, you can watch a video of somebody doing something. You can watch another video of somebody else doing the same thing. They do it in a slightly different way. So what you do is you come up with an abstraction. It's like, oh, okay, so the common stuff between the two videos would be these things, and then the differences would be these things. Okay, so that's the ability to abstract. And mathematics also is all about abstraction. Technical precision is about, after you learn the syntax of a programming language, how well can you apply that when you're actually writing the program? So this part really just has to do with practice. Okay, the more you practice, the better you get. Okay, it is not unlike learning a new language. Okay, so I am an ESL person. Okay, my native tongue is Cantonese, which is really far away from English. Okay, both in terms of the grammar structure and also in terms of sentence structure and pronunciation as well. So it is really just a matter of practice because you're really just learning a new language. And then the last one, second to the last, I think. Yeah, the second to the last is called integrative reasoning. I call this cross-domain reasoning. Okay, so you might have a hobby. Okay, some of you may have a hobby like I like to cook. Okay, but sometimes when you cook, things do not happen the way you want it, right? So you apply some troubleshooting skills, but only for cooking. But then you look at your program not working, and you go like, hey, this reminds me of how I fixed that particular dish, how I found out what's wrong with that dish. I can reapply that technique over here, even though this is programming and the other one is like, just cooking for leisure. So if you can do that, it's called integrative reasoning. You're applying what you learn in a specific domain and then you reapply that to a different domain. Okay, so that's what this is about. It does relate to abstraction. Okay, the ability to abstract leads to integrated reasoning, and then the last one is metacognition, which is about can you see yourself reasoning? Okay, because a lot of times when we think about something, we are not aware of how we come to the conclusion. Metacognition is being able to watch yourself think. Now, why is it useful? Because when you make a bug in the program, okay, and then later on you fix it, okay, so the first reaction is, darn, the program is not working. And then you look into it, it's like, oh, okay, I see there's a flaw over here, and so on and so forth. Metacognition is the introspection of your own thought process of why did I make that bug to begin with? Okay, what was the process in my head? Did I neglect something? Did I forget about something? Or did I make a wrong assumption about something? So it is you debugging your own thinking process. Okay, and that's a kind of really high level, cognitive function. It doesn't mean it is not possible. It just means practice, being aware of this is important and spending the time to kind of think about that is important. Okay. So the document goes on and on. I'm not going to spend too much time on this. The second part of this document shows you, you know, when you're an entry level employee, like when you're applying for a job, what is more important? When you're in mid-career, when you're 3 to 5 years into the career, what is important? When you're a senior, what is important? And also when you're an educator, consultant, or leadership, what is important? So these are just a brief summary. And then, this part is, I think, is really important. What it's showing is if you just take Joe Schmo, okay, an average computer science, professional, and you say, okay, you are really just about average, among all the computer science people. But where are you at in terms of the general population? What percentile are you at? So as it turns out, according to ChatGPT, if you just take an average person, that is a computer science professional, and you compare that person to the general public or the general population, that person would place on the average at 82.5 percentile. Now, is it exactly 82.5? Of course not. Okay, this is just a rough estimate. But this is the 95% confidence range, which means ChatGPT thinks it has 95% confidence that the average person working in the computer science industry is going to be somewhere between 75 to 90%. If you just take the low number, which is 75%, that means an average computer science professional is still having the cognitive ability better than 75% of the general population. Am I, are we understanding all this? Okay. So why is this important? Because it shows you that an average person, which would, by definition, you're going to be at 50th percentile over here. That person will need to change that ranking to what we are seeing over here to become successful in a career. Is that okay? Now, by no means am I saying that you are average, okay? This is just numbers, okay, applicable to the general public. All right, and then the last portion here, or second to the last. So the second to the last portion here, kind of this is ChatGPT's own assessment, and I really cannot say which one is really innate and which one can be learned later on. But this is really saying that in terms of analytical depth, your own innate ability is kind of important, but not super important. Um, the educational contribution, which is what you're doing right now, is really important. Okay. When it comes to abstraction, this is the only one where you're kind of born with it. Most of it, you can train yourself up, to a certain point, but most of it is what you come with. Okay. So unfortunately, this part is has to do with brain structure. Okay, how you process information. So this part is a little bit more innate, but it doesn't mean that you cannot improve it. Okay, you can still will do some reasonable improvement, just not exceptional. Okay, do not expect to make a huge difference from the education system, but you can still improve. This is where you can really make a difference, make huge difference, because the actual innate contribution is low. It's like you don't need to have it to begin with. Nobody is born with this ability. It comes with practice. Okay, so people who practice a lot, they can gain a significant amount of technical precision by just by doing something over and over again, and also practicing and questioning what did I do wrong last time, and then let me make a note here so that I don't make the same mistake again. Okay, um, and I will tell you one thing about this part too. If you like what you're doing, you won't even notice that you're putting effort into it. So I think that's a really important piece is do you like what you do in computer science, in coding, solving problems and stuff like that? If that is what you enjoy, you'll be proficient at it just because you'll be practicing without knowing it. Okay? As opposed to doing something that you really do not enjoy and then you have to spend like 10 hours each day doing it, that would not be very nice. Okay? You will notice that you have spent a lot of time. Those 10 hours will feel like 20 hours. As opposed to me doing programming kind of stuff, I can spend a few days and go like, oh, wow, a few days have passed because I don't notice the passage of time when I'm having fun. Integrative reasoning is just medium in terms of the innate contribution. And once again, education and your own effort into this can make a big difference. And this one is even more. Metacognition, according to this, you can start with almost no or none, and you can gain a lot of that just by being mindful. Okay, you put in your notes. Okay, whenever your program doesn't work and you fix the problem, spend a few minutes to think about how did I come up with the idea that did not work in the first place. Okay, and as long as you keep doing it, you get good at it. Okay, so I think this is all good. And then it even provides, I asked ChatGPT to provide some suggestions of what you can do to improve each dimension. So I'm not going to go over this too much. Okay, that's really not the intent of CISP 300, but I thought this might be useful for some people. Are we okay with this? So if you're really curious about this sort of thing and you want to talk more about it, my office hour is right before the class. Okay, from 8 to 9, I'll be in my office. So if you're really interested in these things, not only that you want to improve yourself just because you have curiosity about these things, we can talk about it. I'm not a psychologist and I don't even have a degree in education. My PhD is in computer science. Okay, but I'll be more than happy to share what I know or what I think I know. What is the difference? What is the difference of somebody says, this is, I will share what I know, as opposed to I will share what I think I know? Confidence? It's more like allowing what I think I know to be incorrect. It's leaving that possibility so that later on I can question what I think I know to see, okay, is that right though? Okay, is that the truth? Okay, so I usually, kind of, it's also lawyer language, right? I release liability of what I tell you to be truth, the actual truth, because it is just what I think is the truth, which does not mean that it is the truth. All right. Thank you for being here in the morning. on a Monday. I know you guys can probably all sleep a little bit more on a Monday. All right, so let's get this out of the way. I'm still recording, so you just missed the part that is not really essential to the class, but it is just a little discussion. Does anyone want to summarize what I just talked about in like 2 sentences? If you guys are too shy, it's okay. All right. So you just have to watch the first 15 minutes from the video. It is not related to the conversation here. The whole thing started when I asked ChatGPT. You can actually read the prompt here. I can I would rather not do that, but I was about to say I can share this entire conversation in ChatGPT. Then I decided, let's not do that. So the first question, the prompt to start it that started this whole thing was, is ChatGPT programmed to flatter users by default? Because if you have not read the news, there was a 16-year-old who committed suicide, and people found out that this 16-year-old had been in a long conversation with ChatGPT about problems in his life, and then ChatGPT somehow just go like, yeah, you can commit suicide, and even provided the means to do it. Um, and some people thought that ChatGPT is programmed to flatter and to kind of jibe with the end user, just so that people put more time into ChatGPT, and that turned out to be not the truth. You can actually turn ChatGPT's personality all the way down to bare bones, which means it would just give you the answer. It won't say, "Oh, that was an insightful question. Let me answer this," or some anything like that. It would just go like, "Okay, I understand your question, and this is the answer." So you can program it to be very direct if you want. Okay, so enough about that too. So now we finally go back to the class content, and we're going to start with conditions and conditional statements today because we are done with assignment statements. So I hope you guys are doing your homework assignment. And let's see, 5 people have turned in the homework assignment. That's good. Okay. So people are making progress. All right. So we are now over here, right? So we'll go ahead and take a look at the module. So the module is already integrated into the ChatGPT TA, the teaching assistant. So if you were to ask it, conditions and whatnot, it will be able to answer those questions. All right. So at this point, with only assignment statements, the only thing you can really do is computation in the sense that, oh, okay, I can figure out the value of this expression, put it into this variable, and then later on I can use that variable in another expression to figure out another value to store into another variable and so on. So you can go straight line computation. But you cannot say, oh, but sometimes I need to do the computation this way, and other times I want to do it the other way. So there's no decision making capability up to this point. So this is what conditions and conditional statements are about. It is about the ability to make decisions. Conditional statements, or the understanding of conditional statements, also paves the path to understand more complex, what we call control structures, which include loops and so on. And I'm going to bump up the font size here, just so that it is a little bit easier for you guys to read on the screen, like so. All right. So we start with what a condition is. A condition is a question that can only have one of two answers. In computer science, we don't say yes, okay? We say it is true, or false, we don't say no, okay? The reason why yes versus no is not a good thing to use has to do with languages. In some languages, if I say, okay, um, did you not go to sleep early last night? Okay, that's the question. And if you actually went to bed late and not early, the proper answer would be a negative. Okay, that's English. But in Chinese, the proper answer, if I went to bed late and my mom asked me, did you not go to bed early last night? The answer would be a positive. It would be affirmative. Okay, I actually did not go to bed early last night. Okay, so it is language dependent. And we don't want anything that is natural language dependent when we are programming. So in this case, we basically just answer with true versus false. Okay, is a statement true or false. So the following are some examples. Is variable x greater than variable y? True or false? Is variable x not greater than variable y? Once again, it's either true or false. Okay, we don't answer with the yes or no because natural languages have different conventions and we are bypassing all of those conventions. And once again, and this is also using a symbol. Okay, we use the greater than symbol to mean greater than, and so on. Okay, so now we look at all the different comparisons. So there are six comparison operators. These are also called relational operators because it is asking how does the left-hand side relate to the right-hand side. So that's why they're also called relational operators. But I personally like to just use the name comparison operators. So when you see me use one or the other terms, they are used interchangeably. Okay. So the first one is greater than, the second one is less than, greater than or equal to. Now, when you're using greater than or equal to, the greater than versus the equal symbol, they have to be in this order without any space in between. Okay, so it literally has to be spelled exactly like this. This is these two combined is the terminal. You do not have a choice of, oh, can I switch the order of these two symbols? No. Can I put a space in between? No. And then we have less than or equal to, we have not equal to, and this is equal to. So the first thing that most people notice is like, ew, that looks like assignment too. Well, what is the difference between the symbol that we use for assignment versus equal to? What is the difference? One versus two of the equal character, right? So you might say, isn't that a little bit confusing? Yes, it is absolutely confusing. And most people will step on this landmine at least a few times. You meant to say equal to in a comparison, and you forget that you need you to use double equal instead of single equal. Those turn out to be some of the most nasty bugs that you can put into a program because in many contexts, it would still be syntactically correct, which means the compiler would not come back and say, hey, this is wrong. You are lucky when it's a compiler error, which means it's a grammatical mistake, because the program would not even run. Okay, the computer says, I don't understand what you're saying. So it forces you to go back and say, oh right, I really meant to do this. Okay, so you're lucky if you make a syntax error. If you use a single equal instead of a double equal when you mean comparison, sometimes it will still compile. Okay, it depends on the context. When it does compile, instead of comparing, it would use the right hand side to update the left hand side, okay, which is what assignments do. And many times it might even give you the code may even work quote unquote correctly in certain cases. So unless you really test the code with a lot of test cases, you may not even notice that there's a problem. And when you do notice there's a problem, the symptom, which means that by the time you detect there's a problem, will be further down, much further down in the execution of a program. So that means these are difficult bugs to find because by the time you see the symptom, the cause of the symptom is already way removed. Okay, so you kind of really have to watch out for these things. Um, you can turn on certain features of a compiler to really warn you about things like this. Okay, whenever you use a single equal in a context where double equal makes more sense, the compiler would not mark you wrong, but it would give you a warning, go like, right here, you might want to reconsider this. Okay, you might want to think about whether you really meant to use a single equal versus a double equal. Okay, so in your CISP 360 class, hopefully your professor will teach you how you can turn on that particular feature of a compiler. All right, yes, how to turn on that feature in the compiler. Go ahead, please. Hmm. No, it does not. And that's why in a trace, if I don't tell you ahead of time, assume this variable starts with a particular value. In the trace, in the precondition, we use a question mark to emphasize that we do not know what value a particular variable starts with. Then you have a problem. Yep. Sometimes it would be, sometimes it would not be. You don't know when it is going to be actually zero. So what you just described, meaning what do you do? What does the computer do when you are comparing a variable that is not initialized to a particular value? The answer is we don't know what answer is going to give you. So the answer to that expression is also unknown, meaning that it can be a true, it can be a false, which means this kind of program, this kind of problem or bug is called, there's a name for that. It doesn't happen all the time. It doesn't happen consistently. It also makes these bugs, super difficult to debug because the symptom, every time you run the program, it can give you a slightly different, symptom. So that's also why you want to make sure that you do not use a variable that is not initialized in any way. Do not use it on the right-hand side of any assignment. Do not use it in a comparison because when a variable is not initialized, you just do not know what value is in the variable. That is correct because there are more than 4 billion possible integer values and you have no idea which particular value is currently in the variable if you do not assign a specific value. There's no automatic. Yep. So by the time you get to CISP 310, which I teach consistently, you will start to understand why that is the case. But until that time, you just have to remember variables that are not initialized in C++ simply have unknown values. Yep. So do not use those on the right-hand side. Do not use those in any comparison. Just do not reference the value of a uninitialized variable. Now, because it happens so often, so many people got burned by it, the compiler is actually smart enough to give you warnings about those things. Okay. Now, just because the compiler gives you a warning does not mean people actually read the warning and actually pay attention to it. So that means in CISP 360, when you actually use a C compiler to compile your code, this is one of those things. It's like read all the warning messages because most of the time the warning messages are warranted. Okay, because just because something is syntactically correct does not mean it is making sense logically. So that's a very good point. Thank you for bringing that up. Okay, so some of these things you can actually jot down in your notes. Okay, maybe not now, maybe when you rewatch the video, because the scope of what we just talked about is beyond this class. Okay, it affects you more when you get onto CISP 360, 400, and 430 than it will affect you now. Okay, but knowing it, having an awareness is a good starting point. All right. So I'm gonna sidetrack just a little bit to talk about note taking. Since since I mentioned taking notes is like, oh, this can be important. You might want to keep track of it. So I found this kind of really interesting web page in GitHub. Somebody spent the time to curate a bunch of resources for note taking. Let me go ahead and bump up the font size a little bit here. So they have open source recommendations. Anything that is open source means it is free to you. Okay, many of these can run in Mac OS, Windows, or Linux. So it doesn't really matter what you're using. You can still use some of these tools, and it's organized in like different type of categories. Native GUI means you can run it in Windows or Mac OS. It just has its own GUI. CLI is command line interface. It means you can run it in a terminal. Editor plugin means you have to first install Notepad++ or VS Code or anything something like that. But it's a plugin in order for that to work. Electron and Turi, I'm not really sure what they are, okay, because I don't use these very often. Web UI obviously is a browser user interface, which basically means if you have Firefox or Chrome, it's gonna work. Okay, it probably has a cloud presence, and then we have the proprietary ones. So if you guys are curious, I can also put it into the announcements so that you have access to this list, so that you can kind of like check out some of those. But they're missing one that is which I think is really useful. It's called Zernal. Okay, Zernal plus plus is the name of the tool. It allows you to use any laptop computer, any notebook computer that has a stylus and a screen that you can write on. So it is free. Okay, 100% free. You can capture your handwriting. You can also just slap in some images if you want to. You can also use this in conjunction with a PDF. So if your professor, not in this class, but if your other classes, your professor gives you like a boatload of PDFs, you can just load the PDF and then you can start to highlight, on the PDF. Okay, so I think it's a really cool tool if you are into using a laptop computer that is capable of using a stylus. Okay, like what you're doing here. So what type of laptop is that? Okay. So is the handwriting part okay, or is it lagging behind a little bit? It's workable? Okay, all right. So this is a tool, that you might find useful, okay? You don't have to buy it, okay? You just go ahead and install it. If this is not what you want, uninstall it. No big deal, okay? So they neglected to talk about Zerno in on that list, which I think is actually pretty useful. And I personally use Supernote as a tablet, okay, but that's expense, right? That's money they have to spend, and I don't necessarily recommend using solutions that cost extra money. And the one that is mentioned over here already that I also recommend people to look into, maybe not right away, but at some point, is called I think it has it, but let me double check. It's called Joplin. Yep, it does. So Joplin is interesting because it has a web UI, but it also can be installed with a kind of native, as a native app. It allows you to type your notes using Markdown. Markdown is actually it is a markup language, but it's a very simplified markup language. So they play with the name and call it Markdown. So Markdown I think is supremely useful because you can use it in many applications. Okay, I think Google Doc is starting to recognize Markdown formatting, and all my notes, by the way, are in Markdown. Now, what you see here is the HTML rendering of the original Markdown document. But if you go all the way down here, I have to remember where I was. So if you go all the way down here and you go to view the source document, I'm going to open it up in a separate tab just so I don't lose the other one. So this is already in Markdown, I mean in HTML rendering, but if you click on raw, it will give you the actual Markdown. It's plain text file, which means any notepad can do this, but at the same time, it is encoding the formatting that eventually turns into something like this. Even this diagram is specified in plain text. So Markdown is not certain parts of Markdown is really easy to learn. Other parts it's like, you might need to spend some time to get used to it. But in general, in the long run, I think it is worthwhile to learn it, but it's kind of up to you to decide, do you have the time to kind of learn about these things? All right, so getting back to logical operators. So comparisons are useful, but they cannot express all the conditions that the program requires. So we'll get back to this later. So all this is doing is to say, yeah, there are these things called logical operators, but we're not going to talk about it yet, okay? Because we want to focus on the statement now. So now that we have, the concept of a condition, and we also learned about assignment from the previous class, so we are going to take a look at how, if I give you two variables, okay, x and y with known values, so they're not uninitialized. By the time you get to this code, it's already initialized with certain values. I want to find the maximum of those two and then store the maximum in a single variable z. In other words, I want to do what the mathematicians would say, z equals to the max of x and y. Okay, that's what I want to do. So how do we do it? Well, I think you guys know how to do it intuitively, right? If I just give you two numbers, 65 and 32, and I ask you what is the maximum of these two, you guys go like, that's easy peasy, 65, right? So you know how to do it. The question is, can you summarize the processes going on in your head to get to the maximum and write out the process in C++? So that really is the important part. So just because you know how to do it does not imply you know how to describe the process. So in the description of the process, the first abstraction, remember, we talked about abstraction earlier in the class. So the first abstraction is, let's not talk about concrete values. Let's not talk about 65 and 31. Let's talk about a number that we call x and a number that we call y. So x and y are variables. They are placeholders, one for each of the number that I'm giving you. Okay, so instead of referring to, oh, the maximum, the maximum, the maximum, I'm just going to be lazy and use another placeholder that I call z to represent where I need the maximum to be stored. Okay, so once again, we are already practicing abstraction here. Okay, because we are trying to go from concrete examples to a process that works on all, anytime I give you two numbers, this method will find the maximum. Okay, so that is called the abstraction process. So every program is an abstraction of a to of how to solve a problem. So the code to do that looks like this in C++. Okay, it says if x is greater than y, z equals to x, else z equals to y. Okay, so now some people can look at this and say, oh, this is really clear. I know exactly what that means. Other people can look at exactly the same code and go like, I'm not really sure how the text description corresponds to what the program or what the computer is supposed to do. So now we're looking at two separate things. One is the behavior of the program, and the second one is how we represent that behavior. How do we specify that behavior? So your job, and also mine, is to make sure that we know one to one, okay? If this is how we want the program to behave, this is how we represent it in the program. So that association is important. Okay, that really is the key to almost this entire class. Okay, CISP 300 is all about understanding this is what I want the program to do, and this is how I represent that in text, in program code. Okay, so in this case, I use a trail map to represent a general conditional statement. Okay, it's an awful kind of picture here, but just kind of imagine this is a trail map. Okay, it's a trail map, and there's a sign at the entry point of the trail. Okay, so think of this as a trail. Since I'm recently getting into off-roading as a hobby, okay, so one of these days you may see that Tech is absent from class. What's happening? My car broke down on the trail, and I'm kind of by myself and he's stuck. Okay, but think of this as a trail, and think of this condition here in a box as a sign for drivers to read. Okay, so it has to be a question, okay, in that sign, in the post. It can be a question like in this case, for four wheeling. It can be a sign that reads if your vehicle has a clearance, okay, how far the bottom of the car is from the ground. If your clearance is less than 8 inches, go for this route. If your clearance, if it's the other way, go for the other route because the other route may be more scenic, okay, but it has rocks, it has holes, it has a lot of things that require a higher clearance because otherwise you'll be stuck. So now the driver at the entry point of this trail would read the question and evaluate, okay, maybe get off the car and actually measure the clearance and go like, darn it, I'm driving a Prius. And then the Prius has to go to the left because the condition is true. On the other hand, somebody who's driving a Jeep Wrangler Rubicon would go like 8 inches, no big deal. I've got 12 inches. Okay, fine. Go for the more rugged route. Is that okay? That is the mechanism of a conditional statement. Single entry point, two paths to proceed, but to determine which path to proceed, you have to answer a question with an answer of true or false. If it is true, you go for one path. If it is false, you go for the other path. But that's not all for a conditional statement. So for the Prius is going to go for a what we call a bypass. That's not very scenic, and then get out, at this place over here. The Wrangler would go for a really scenic but a little bit more difficult path, but they both will converge at the end of this section of the trails. Is that okay? That is really important, okay? To understand what a conditional statement is, most people get the branching part, okay? Oh, okay, there's a branch. We have to answer the question to select one of the two branches. But it's equally important to understand that the two branches merge before proceeding to whatever is next in the trail. Are we doing okay so far? And also, these paths are unidirectional, okay? You can only go in one direction, but not the other direction, okay? They are all directional. So if you try to back up your car, turn around, the other cars going in this direction, they will all honk at you and go like, no, wrong way, turn around, okay? And think by the end of this lecture, most people will just remember Prius versus Wrangler. Yes, we got it. And then forget everything else. All right, so that's the structure of a conditional statement. So if that is the structure of a conditional statement, this is somewhat correspond to the code that we have, okay? The question is x greater than y? Okay, if it is true, we go on to this side. If it is false, we go on to this side over here. What do we do on this side? We just go like, this is, I didn't use an equal symbol, so that I don't confuse it with comparison. So when we see z and then a left arrow x, that means, z gets the value of x. It is the same thing as an assignment statement that says z equals x, okay? But to avoid the confusion of is it a comparison or is it an assignment, I just go like, okay, let's just use another symbol to represent your assignment. So now we have a kind of more of a official flowchart. So the flowchart looks like this. This one does use C syntax. So the starting point is the little um, round thingy up there. These two are called terminators. They basically mark the beginning and the end of a block of code. So this is the starting point, this is the ending point. The diamonds serve two purposes. They can either represent a fork, which means you have one entry point and two outgoing, or they can also represent a merge point, which means you have two incoming and only one outgoing. That's what diamonds traditionally are used in a flowchart. So once again, it is representing really the same thing. X is greater than y is true, go this way. X is greater than y is false, go the other way. But the two branches, the two alternatives merge before proceeding to whatever is next or following the conditional statement. So these are really just different representations of exactly the same thing. Okay. Now, how you map the syntax to the actual diagram, to the behavior of the code, that's kind of up to you. Okay, some people are more visual, so the picture means more. I'm not a visual person. I do not like flowcharts. In other words, I do this only because the curriculum calls for it. Okay, but otherwise, when I program, I do not see flowcharts. I do not use flowcharts. I do not see flowcharts. I just innately kind of know what control structure I need to use. Okay, so flowcharting is good at the beginning, but I think at some point, everybody really should transition out of needing a flowchart before they start to code. So now we get to the more important part, which is, what is the syntax of a conditional statement? So this goes all the way back to BNF, okay, module what 0440, okay. So it goes all the way back to BNF. No, um, I cannot remember the meta syntax name. It is what NF? BNF, right? It's BNF. Okay. So what that means is this is the token representing an entire conditional statement. So the other side says, okay, these are the parts of a conditional statement. This part here, they're boldface, which means they are terminals. Okay, that means the parentheses are actually required. Okay, because in mathematics, most people say, well, the parentheses may be optional. No, not in programming. Okay, in programming in C++ and all languages that are derived from C, the condition in a conditional statement must be surrounded by parentheses. You do not have a choice. So what is inside the parentheses is what I would just call a condition. Okay, so we'll look at the condition later on. And then it is followed immediately by a then statement. And it also has an optional part that is an else part. Okay, optional means you can have zero or one occurrence of that thing. Okay, or in more plain English, it means you can have one or none. Okay, so are we understanding what optional means in this context? Are we good? Okay, all right. So now we take a look at what can possibly be a statement. A then statement is really just a statement. So at this point, okay, up to this point, the only statement we know is an assignment statement. But then later on, we'll see, wait, there are other kinds of statements. But at this point, the only thing that we know is an assignment statement. What about the else part? So the else part is also kind of interesting. The else part must start with the else in boldface, which means it's a terminal. So you have to use the word else, E-L-S-E, to start the else part. And then it has to be followed by an else statement. An else statement by itself can be a statement. And this is the confusing part. A statement can also be a conditional statement. This is in addition to what we already learned in assignment, that a statement can be an assignment statement. This is in addition to that. So that means at this point in time, statement can expand to an assignment statement or a conditional statement. And we keep adding to what statement can expand to, because later on we'll have the various loops that can also be statements. So are we understanding that part? All right. Because that part is actually important. As we build up what can be a statement, it is important. Okay. And then I'll start to get into what the compiler uses, or what method does it use to determine, oh, okay, I can see this is a conditional statement, or oh, I can see that this is an assignment statement, or I can see this is a while statement or a do statement. So I will kind of give you an inside view of what is inside the compiler that can help it determine which one it is. The reason why I would do that is because the more you understand the tool, in this case the compiler, the more you will understand, why do I need a semicolon here? Or why do I need to start this whole thing with the word of while or if or do? Okay, because the more you understand the tool, the more you understand how to use the tool properly. Okay, so that's also something that I would talk about, as we go on to talk about more syntaxes. Do we have any questions about the syntax up to this point, the BNF that relates to a conditional statement? Yes, it is because these are rules in addition to what we already have from the assignment statement module. In other words, okay, let me go back to the other one just so that I can completely talk about how to read the BNFs. So this is what we talked about last week, and it has the BNF of mm, somewhere. I have to find it too. There we go. See, it has this. So an assignment statement is an assignment followed by a semicolon, but a statement can be an assignment statement. So, so this means, okay, from your perspective, taking notes can be useful. In other words, have a whole sheet of paper, or in your case, have one whole page that is dedicated to the cumulative list of BNF notations. Okay, so integrate this, okay, onto that little sheet of paper. Okay, this is what we talked about last week, and then integrate this, which is what we are talking about now, onto the same piece of paper. So that means as time goes on in this semester, that list will get longer and longer, but then you also get a view of, oh, okay, so when something expects a statement, it can be one of these things, okay? Because we'll talk about the block statement and stuff like that too. But when I write these modules, I do not do the back referencing because I want to focus on one little thing. Okay, but they're all cumulative. Okay, so that means, from your perspective, if you spend some time to compile the list of BNFs that are specific to C++, then by the end of this whole semester, you would have a really kind of partial list of what really matters in C++ programming, but it is helpful, okay? Because when you're starting out, knowing how the whole thing operates can be useful. Okay, you don't have to do it right away now. I mean, you're supposed to spend an hour for every hour that you're in a lecture, so use those 2 extra hours for stuff like this. Okay, you can just jot down some instructions to yourself. It's like, okay, I want to make a list of all the BNFs that are introduced in this class. Okay, so make it a separate sheet of paper if you're on paper, because there will be some additional stuff that we're going to be adding to the list as we go on. All right. Do we have any questions about this before proceeding? Yeah, go ahead. Hmm. Yeah, yes. You can branch out again after that merge. So the next thing following that specific part of the trail can have another branch. But when we talk about a single conditional statement, then the answer is no. They all have to merge to the single point. The two paths they all have to merge to the single point before exiting. Let me go back to the graph here so we can reference it. Is this okay too? Because it really is representing the same thing. Okay, so go ahead. So if you want to express of ending, um, so okay, let me ask you this question. Does it mean that when it is false, you simply do not have anything to do? You just kind of bypass the whole thing? Or do you actually mean that um, end the whole program, terminate the program? So if you say end of program, it implies you're terminating the whole program. The program should end execution. Is that correct? So we do not have any um, syntax level specification for that. In a real program, there really should not be a whole lot of need to terminate the entire program because something is false. Now, does it not happen entirely? No, it does happen, but not at this kind of level that we do programming. At least in the 4 year, at least in the 2 year college or even the 4 year university, you would encounter. I don't think you would encounter any program that has to handle that case. Like if this is true or if this is false, we have to terminate the program execution entirely. So you mean there's nothing to do on this side, right? Yeah. So in that case, you're basically, we actually covered that already because remember, this part is optional. So if this part is optional, that means if you don't specify the else right after the then statement, then you don't have an else part, which also means if the condition is false, then there's simply nothing to do from the assignments from the conditional statement itself. So is that okay? Okay. All right. Yeah. So the a part of the answer to your question is this part is optional, which means if the condition is if the condition is false and you don't have anything to do, then don't specify the else part. Then there won't be anything to do when the condition is false. Okay. All right. And any other questions before we proceed? Yes, we do not. That is correct. So in a conditional statement, there are no semicolon for the conditional statement itself. Okay, so if your then statement, okay, so look, if you look at the then statement, it has to be a statement, and if that statement turns out to be an assignment statement, that assignment statement still needs the semicolon. All right, we can take a look at the syntactical. Yeah, let's actually do that. Okay, let me use my tablet and uh, okay, it's here. I was thinking if I forget my stylus, then it's useless. There we go. Okay. So what we'll do is I'm shifting to the tablet and use it kind of like a whiteboard, and we can maximize the screen. So now we're going to go, give it if x is greater than y, z equals to x, semicolon, else z equals to y, semicolon. All right. So you look at this and go like, but tech, weren't we using multiple lines? Yes, we were. But in C and C++, a line feed, which is opening a new line, and also the indentation, those are all meaningless. Okay, everything boils down to, oh, it's really the same thing as one single white space. So that's why you can write the entire code that we were looking at on a single line. Okay, so now we look at this and we say, okay, how is the compiler going to parse this? Okay, so first of all, we have the if, we have the open parentheses, these are all terminals. Okay, so both of these do not really do much by itself. Okay, but then we see x is greater than y. Okay, so this becomes the condition. And I'm going to use angle brackets here just to emphasize that this is a token. This is the condition token. And then it will see the close parentheses. So at this point, there's no conclusion either. And then it will see z equals to x. This entire thing is then interpreted based on what we learned in module 0012 as an assignment statement. So this becomes an assignment statement, which is a token, which then becomes just a statement. Now there are a few parts from here. Oh, why is it? Yeah, there are a few parts from here to go to this point, but I'm just kind of simplify the whole thing. And then we see the word else, and then we see another statement here, which is also an assignment statement by itself. ASIGN statement, which also turns into a statement. So now we have all the parts because now we can say, oh, okay, so if we go all the way back to the syntax specification, now we see not this one, but this one here. So now we see, oh, okay, there's a if. Okay, let me see if I can just kind of, let me see how to do this. Okay, I know how to do it. I am going to do a really kind of, I wouldn't call it a nifty trick, but it is helpful. So I can just open this window by itself and make it always on top. So this way I can take one part of one window and kind of overlay it on another window. So this way we can kind of see both parts at the same time. So I think this can be helpful. So now we can say from the compiler's perspective, it says, okay, do we have the terminal if? Oh, sorry, the other way around. Do we have the terminal if? Yes. Do we have the open paren terminal? Yes. Is it followed by a condition? Yes. Do we have a close paren? Yes. Do we have a statement for the then statement portion? Yes. Do we have a else part? Now, that's a tricky question because to determine whether we have an else part or not means whatever is right after the then statement, is that the word else? Here's my then statement. Ah, yes, we find the word else, the terminal else, right after the then statement. That tells the compiler to go like, oh, okay, in that case, expect another statement as the else statement. Do we have another statement as the else statement? Yes. So that's basically how the compiler works. Okay, it will take some clue from whatever it's parsing and go like, okay, if I am seeing this, what else do I expect? And then it will look for those things in that order. Are we doing okay so far? All right. So the difficulty of this class, okay, and also just generally speaking, learning a programming language has to do with the syntax is one part, okay? These are just rules, and then we have to look at an actual piece of code and say, okay, how is that interpreted by the computer? So that's one aspect, which is really just syntactical, right? The other aspect that is also equally difficult for some people is to look at the code, okay, in text, and even after you look at the structure of the code, and then you go to, oh, but what does it actually do? So the flowchart is really kind of more of a easier representation to show us what does it actually do. So there's the concept of what it does, and then there's the representation of how do we tell the computer this is what we want you to do. And making those two to link up is kind of a difficult part. Okay, what actually has to occur in your mind to associate, oh, I read this code, it means this in terms of behavior. Each person has a different path to that particular understanding. So I can't really tell you exactly how you can make that association. Okay, some people just know it right away. Some people might take a little bit of time, of trial and error. So any questions at this point? No questions? All right. So relating this back to what we talked about at the very beginning of the class, this is technical precision. Okay, because it is telling you this is the syntax. If you miss this semicolon here, the compiler will complain and go like, "Bleh." Okay, not good. If you miss this else here, but this is actually what you meant, guess what? The compiler will compile, but the program doesn't do what you think it's going to do anymore. Okay, so this is why it is important to understand the perspective from the compiler. What does the compiler actually see? Because then you can understand, oh, okay, so that means I can have some really, really nasty bugs if I forget to do certain things. All right, so we can move on to logical operators. Okay, so logical operators are useful when you need to combine a few comparisons to become a single condition. So I'm now extending the program to handle one more variable. So I'm giving you three values, okay? And they are stored in the variables w, x, and y. So instead of using two, I'm giving you three now. But I still want you to tell me what is the maximum of the three and store that in Z. So I'll be understanding the task, what we want to do. I give you three values. You need to find the maximum and store the maximum in a variable called Z. Okay, so the structure of the code is going to look like this. Okay, the underscore is simply meaning that C1 and C2 is just a placeholder. I want to figure out what C1 is and what C2 is. In other words, I want to, well, there are a few things actually. So if we just read this in English, it says if C1, then we confirm that W is the maximum, so let's store it in Z. Else if, which means if C1 is false, then we go to the else if here. If C2 is true, but if C1 is false, but C2 is true, then we confirm that X is the maximum, and let's store that to Z. The only time we get to the else on line 5 is when C1 and C2 are both false. Then we confirm that Y is the maximum because, hey, you only got three variables. If the first two are not the maximum, then the third one has to be the maximum. Does that make sense? So that's why, on line 6, we just conclude that, okay, of the three, W, X, Y is now the maximum. Okay? But the question now is, but what do we put in the place of C1 and C2? In other words, in one single condition, how do we confirm that out of the three variables, W, X, Y, that W is the maximum? How do you do that? Well, all we have to do is to scroll down because the answer is down here. So the way we want to express that W is the maximum is W is greater than equal to X and W is greater than or equal to Y. Ampersand ampersand is the representation of what we normally know in English as just and, A-N-D, and. Is that okay? All right. But do we actually understand what and means? Okay. In other words, you get into McDonald's. Okay. They have a special promotion, and let's say they have toys. Okay, from Cars the movie, the characters, and they say if you are a child younger than say 10 years old, you can get this toy regardless. Okay, so 10 or younger, you can get this toy. Okay, as when you make a purchase. On the other hand, if you're older than 10, but you're also a man, okay, male, you also get this toy. All right. So that's an or, not an and. Darn it. Okay. I have to change it to use an and somehow. Well, we can do that. Okay. So if you are a kid, 10 or younger, and you purchase a kid's meal, then you get a toy. Okay. So that means somebody who just walks into McDonald's and go like, "Hey, I heard that you guys have a promotion. Can I get a toy?" But I'm not making any purchase. I don't want to spend money. Do you get a toy? Nope. So what if I go into the store and I go like, "Okay, the kids meal looks kind of interesting. I'm gonna go order the kids meal." Do I get a toy? Because I'm not younger than 10, right? So it has to be someone who's younger than 10 and ordering the kids meal menu in order to get a free toy. So that means both conditions, both the left-hand side and the right-hand side of the and, they must be both be true in order for the and itself to be true. If at least one side is false, the answer is false. Okay, so that leads us to the next section. Okay, and it talks about conjunction. So conjunction, this word, is a fancy way to say and, okay, which is what we just talked about, okay? So if we already know this is just and, why do we use this fancy word called conjunction? Because conjunction is what mathematicians use. It is also used in other contexts, in some of your other classes. So that's why, we also want to know that what we know as and as a word is also called conjunction in mathematics. So one way to represent, what ampersand ampersand or conjunction means is to spell out every single possible case. True and true is true. True and false is false. False and true is false. False and false is also false. Which means the only time a and or conjunction can be true is when both sides of the operator are true. Okay? But we also usually use a truth table to represent exactly the same thing, except it is just kind of nicely lined up. Okay, so that means x and y are what we call independent variables, which means the value of x does not impact y or vice versa. So that means when x is false, y can be false or true. When x is true, y can also be false or true. So this spells out all four possible cases when you only have two independent Boolean variables. The word Boolean is just a fancy way to say, oh, that value can only be either true or false. That's what Boolean means. It is named after Boole, Boole, who is what is, and that's the last name of the mathematician who came up with Boolean algebra, in the first place. Okay, and then the last column, or column 3, is just telling you the result of the expression of x and y. So each row tells you a specific case. I'll pick the second row. The second row means when x is false, y is true, then y and x and y is going to be false. So that's how we read a truth table. These are definition stuff, okay? So whenever I talk about definition stuff, you might want to consider putting all the definitions in one place, okay? Because even though it is in the notes, okay, I kind of know where to find it, but finding this in an exam quickly is something that you want to be able to do. Just because you know it is in the notes and you have a printout of every single note in this class does not mean that you can quickly locate this information, the definitions. So the one thing you can do is to put all the definitions on one single sheet of paper, because that way it's quick for you to look up the definition of stuff. Okay. Now, initially, especially for people with no programming experience prior to this class, I would highly suggest to those people to put all the definitions in one place. On the other hand, if you took a class in high school, for computer science, you took the AP test, or whatever, right? And you have some experience with Python, you might be knowing all this stuff already. Okay, except things are just represented a little bit differently, but the concepts are the same. So for those people, I go like, yeah, maybe you don't need to kind of write down everything in your own words, in your own notes on a particular page. But if you're new to programming, this is important. Okay, this is really important. And I'm just gonna waste a little. I want to relate what I'm talking about now to things that I talked about earlier in the class. So if I were to bring up that page, I think I can probably find it in a different way. I think it's called cs.pdf. All right. So this is the document that we talked about in the first 15 minutes of the class. The third item, which is technical precision, this has to do with knowing what the symbols mean. It has to do with definitions, okay? And that is something that you can build. It's almost entirely non-innate, okay? Let me ask you this question. Who from birth understands that ampersand ampersand is conjunction and the truth table of conjunction? I can give you the answer. Easy. No one. In other words, this is 100% acquired, which means you can totally master the syntax and also the operators, the meaning of the operators, just by putting time into it. And part of that time is taking notes. Part of that time is making sure your notes are organized and you refer to it and you read it kind of like just to make sure that you can quickly recall, okay, what each definition is. So that is why what we talked about in the first 15 minutes of the class is actually relevant, okay, because it leads to actionable things that you can do in the class. Is that okay? All right. All right. So we only have about 15 minutes left, but that's okay. We will go as far as we can possibly go today and then to pick it up on Wednesday. So the next one is called disjunction, which is really just the English word of or, okay? So in this case, it's kind of like a the flip side of an and, okay, in a strange way. So the only time a or is a false is when you have false or false. That's the only time you have false. If at least one side of a or is true, then the whole thing is going to be true. Okay, which is I hope consistent with your use of the word or in English or in your native tongue. So in the truth table, this is how or is represented. False or false is false. False or true is true. True or false is also true. True or true is true. And that spells out every single possible case of using that operator. Is that okay? Okay. Conjunction is and, disjunction is or, but not either or. Okay. Either or is different. Okay. So you might want to jot down the note because I didn't quite mention it in mine. So you might want to mention in your own notes that either or is not a regular or. Okay. This is a regular or. And the last one is also simple. Okay. We call it negation. Big fancy word for not. Okay. In English. So the truth table is pretty easy. The symbol is an exclamation point. So the exclamation point in C++ is actually an operator when it is placed to the left-hand side of whatever you want to negate. So the negation of false or not false is true, not true is false. The truth table is a lot simpler in this case because it only involves one single independent variable, and that's why it only has two rows. Not false is true, not true is false. Are we good so far? Okay. So if you're new to programming, okay, if you have done some programming in Python and done some programming otherwise, today's class may be just a review of what you already know, and you go like, oh, okay, the syntax is a little bit different, but I get the concepts, okay? But if you're new to programming altogether, this can be quite a bit of stuff already, okay? And taking notes and reviewing your notes and going and interact with the GPT teaching assistant too, okay? You can say, give me some examples to confirm that I understand, conditional statements. Now, what we have not talked about is the structure of what we just used earlier. Okay, in other words, if you see something like this, there are two conditional statements in it. And I would use the next 2 minutes just to give you an idea of what we'll be talking about on Wednesday. This is one entire conditional statement. But from the BNF, it says a conditional statement is a statement. So it turns out what is highlighted here is the else statement corresponding to the overall, this entire thing, which is also a conditional statement. This is called nesting, okay, which is containment, a statement being contained in another statement. Now, when you look at this, okay, it does not really look like there are two conditional statements, one being a part of the other one. But to the compiler, that's what it sees, okay? It sees one conditional statement where the else of that conditional statement is by itself an entire conditional statement by itself, which also has its own else, okay? So the module actually talks about how to parse this, how do we figure out the structure of this code. so that we can actually draw out the flow chart of this whole thing. Excuse me, we're still in class. Wait until your professor is here. Um, so that's kind of important. Okay. So if you have read up to this point, great. And read ahead of the class because that's going to help you understand what we'll be talking about on Wednesday. Okay. If you have not read up to this point, then obviously, my suggestion is to read up to this point and relate it to what we talked about today. I will upload the lecture in just a moment. Okay, it'll probably sometime around 1:30 at the earliest because I do have another class right away, just in the next room. So you might have to wait until 1:30 before the recording is up. Okay. So I'll see you guys on Wednesday. And once again, thank you for showing up today, because otherwise I'll be talking to an empty room. So is that helpful? Instead of having you guys to just read the material and try to understand everything by yourself. Okay, excellent. So I think it really has to do with you guys asking questions right away, and I can address the questions right away too. So that's all good. Excellent. So thanks for being here, and I'll see you all on Wednesday.